Alright, so now that we know the terminology and also some of the symbols for doing these hypothesis tests of one proportion, we're going to go ahead and take a look at an example of this. So, a recent study conducted by the National Institute of Retirement Security reported that 4.8% of working millennials, people born between the years of 81 and 91, are saving adequately for retirement. In a recent study of 400 millennials whose highest degree was a high school diploma, reported that 16 out of 400 millennials are saving adequately for retirement. Is there evidence to suggest that the proportion of millennials whose highest degree was a high school diploma that are saving adequately for retirement is less than the population parameter reported by the National Institute on Retirement Security? Test this at the 1% significance level. So, first step. Define the null and the alternative hypothesis. The null hypothesis is it doesn't matter how many samples that we take, but we would assume that the proportion of the sample is equal to the proportion of the population. So no matter how many people I select, it's going to be the same proportion no matter what. In other words, that 4.8%. Now we look at the problem, and the problem suggests that is the proportion of students that are saving adequately for retirement is less than the population parameter. All right, so right here we have the phrase less than. So that would indicate that P is less than mu sub P. All right, so generally wherever the question is asked, you read it and then you determine if that's going to be the alternative hypothesis. All right, so that's fairly easy. The next step is to be able to get some of the population as well as the sample data. So mu sub P. Mu sub P is the population proportion. It is stated that the population proportion is 4.8%. That's given to us as a claim made by the National Institute on Retirement Security. So that's 4.8%, or in other words, 0.048. Now, P is going to be the sample proportion. In this case, there are 16 out of 400 people with a high school diploma that are millennials that are saving adequately for retirement. If we type that into our calculator, that's going to be 4%. Notice that there's a subtle disparity between 0.048 and 0.04. Is there enough of a difference in the context of 400 people? So 400 people is a lot, but is it enough to say that there's evidence to suggest that the proportion is actually less? Q, 1 minus P, 1 minus 0.04 is 0.96. Number of samples, 400. And then finally, the significance level alpha is given to us in the problem. And we know that because the very last line says that we are going to test at the 1% significance level. All right, so whenever we see alpha, that's the same thing as the significance level. So the alpha level is 1%. All right. So make sure that you're okay collecting the variables. Make sure you're okay defining the null and the alternative hypotheses. The next thing we're going to do is we're going to go ahead and draw the graph. Okay, so here's our distribution. And I'm just going to rewrite that the alternative hypothesis was P less than mu sub P. And that's important because that tells us which of the three tests that we are doing, left tail, right tail, or two tail. Since it's a less than problem, it's going to be a left tail test. So we're going to shade in this region to the left. That's the reject region. Oh, excuse me. And the fail to reject region is going to be the unshaded region. So this is our reject region. This is our fail to reject region. Remember, the range of values on the distribution is 0 to 1, and then the cutoff point is going to be, in this case, because it's the left tail test, alpha, and alpha we said was 1% or 0.01. All right, so make sure that all makes sense before you go on to the next step. But again, you look at the alternative hypothesis, and the alternative hypothesis determines left tail, right tail, or two tail. It also determines whether it's going to be, for the cutoff point, alpha, 1 minus alpha, or alpha over 2 and 1 minus alpha over 2. Next thing we're going to do is we're going to compute the p-value. All right, the p-value is done in 2 steps. To get to our p-value, the first thing we need to do is we need to compute the variable sigma sub p. Sigma sub p is the square root of p times q divided by n. Remember, we said that p was 0.04, 16 out of 400. We're going to multiply that by q, which we said was 0.96, and then we're going to divide all of that by n, which is 400. Now, to put this in the calculator, you're going to use your square root key. You're going to type 0.04. You're going to multiply that by 0.96. You're going to divide by 400, and then you're going to close the parenthesis. All right? That's if you don't have a symbolic manipulator. If you do have a symbolic manipulator, you can just type it in exactly as what it says up top there. So I'm going to type this in my calculator. So square root of 0.04 times 0.96 divide 400, and I get 0.0097. I'll just say 0.01. All right. If I were to go out to 4 decimal places, it would still be 0.01 with the rounding. Technically, it's 0.009797959. All right. Not that it matters that much at this point, so 0.01. All right. Once we have that, now we can find the z-score. Z is p minus mu sub p divided by sigma sub p. We know that p is 0.04. We know that mu sub p is 0.048. Okay, and I'm getting these numbers all the way back from the beginning of the problem. So remember, in our variables, mu sub p is 0.048. P is going to be 0.04. So I have 0.04 minus 0.048, and then we're going to divide by the standard deviation that we just got, 0.01. I'm going to type that in my calculator really quickly. So 0.04 minus 0.048 divided by 0.01, and I got negative 0.8 as my z-score. So z is negative 0.80. Now, we're going to go to the z table. Okay, and what we're going to do is we're going to convert. All right. So if you go to the negative side of your z table, and I'm going to look this up, hopefully you're looking this up as well, negative 0.80, I got 0.2119. So the p-value is 0.2119. All right. Now remember, this is the probability, okay? So remember, this is the probability that this event could occur. About 21% probability, which is a very high probability. All right, it's very likely. Usually if we start having things that are around 5%, 4%, that's when it starts becoming a rare occurrence. All right, but 21% is certainly not a rare occurrence. All right, so make sure you're okay computing the p-value. Okay, and the last thing that we're going to do is we're going to plot the p-value on the distribution that we had from above. Okay, so remember we had this distribution. All right, I'm just going to recreate that distribution down here so that way we can just get a clear picture of how we're doing this. You don't have to recreate the picture when you're doing this on tests and quizzes. All right, so remember it's a left tail test. we have 0.01 from the alpha level. The range of values is 0 to 1. Remember, directly in the middle is 0.5. All right, so because remember 0.5 directly bisects the graph. So if I was to plot 0.2119 on the graph, our p-value might be right about here, about halfway in between there. The tail's exaggerated, so this is our p-value, which is 0.2119. And clearly the p-value falls in the fail to reject region. Okay, because remember the fail to reject region is the unshaded region. If it was less than 0.01, it would fall into the reject region. So in other words, if the probability was less than 1%, then there would be enough evidence. However, because the p-value falls in the fail to reject region, what we're going to say is that there's not enough evidence to reject the null hypothesis. Okay, so I'm going to type that out. We're going to say, since the p-value falls in the fail to reject region, there is not enough evidence to reject the null hypothesis. Okay. If the p-value were to fall in the fail to reject region, then there would be enough evidence. So then the last thing we have to do is we have to actually answer the question. And the question is there evidence to suggest that the proportion of millennials whose highest degree was a high school diploma is less than what's represented by the retirement security? Okay, so here's how we're going to answer that question. We're going to say no. There is not enough evidence to suggest that the proportion of millennials whose highest degree was a high school diploma that are saving adequately for retirement is less than the population parameter. All right. Essentially, if you get an FTR, that's just the answer to the question is no. All right. So every time you get a fail to reject, the answer to the question is that there is not enough evidence to suggest that the alternative is true. Okay. So ultimately, we fail to reject the null hypothesis, and we reject the alternative hypothesis. All right. So go back through, make sure this is all okay, and then what I would recommend is that you go ahead and try the next problem on your own. See how far you can get with it. And then after that, watch the final video in section 14 as I'm going to work through the problem with you.